appreciate you that we taught. We really appreciate those folks coming. My name is Mike Rossetti. I'm a volunteer board member for the ASEA Hawaii Educational Foundation. The organization is a 501c3 organization, which is an educational nonprofit organization that is attached to the local ASEA Hawaii chapter here in Hawaii. And our purpose is to educate and train the existing workforce as well as the workforce that's up and coming from high schools and colleges. The monies that we receive go to scholarships for high school kids in the local area. Since AHEP has been created, I think it was 2008, we have raised over $2 million for scholarships for high school kids. And I believe that every day is a good day to learn, and I also believe that if you want to impact somebody's life, give them an education. So with all that said, this course is a controlled environment, which means once the presenter starts, the doors will be manned by our volunteers. So we have Shauna at this door. Looks like she's outside manning the door already. She's one of our volunteers. And we have Taylor, who's on this door. If you need to go to the bathroom, we can't let you back in. If you want to take a phone call and you go out, we can't let you back in. So hold tight, you get through the course, and you can get the 1CU credit that you deserve. Okay. Any questions on that for the administrator? No? Good. Okay. With all that said, I'd like to go ahead and introduce our speaker for today. I think we saved the best one for last, I think. Okay, so Dr. Jerome Heath is a retired professor of computer science at Hawaii Pacific University. He holds a PhD from the University of Hawaii in communication and information science. Dr. Heath taught both management information systems and computer science at the university level. Presently, Dr. Heath is retired from teaching and is writing textbooks. The textbooks include the e-book on computer design and the e-book on software development. These books are available from Google Books under Dr. Jerome Heath. Dr. Heath also has developed the concept of harmonics in nature, which describes how random processes in nature react to constraints to produce symmetrical patterns. I know this is intense, right? Which in turn form the basis for the world as we see it. I'd like to get that book. This and other short books are on Nook Books under Jerome Heath. With that, warm welcome please for Dr. Heath.
Thank you. I allow questions. I don't know if in a room this big people feel open to ask questions. I'd like questions if you have them. I start this out with something interesting. This is a picture I took yesterday. The sun is up, but you can look right at it. You don't burn your eyes because of fog. They call it Kona Winds. The winds are coming from the volcanoes and sort of, oh, that's how you change it. Okay, so the fog comes in, and then you have this haze in the air, and the sun is up, but it's kind of hidden. I had in the past take some pictures of fog sunrises, and you notice the reddish color in the sky, and it reflects on the aloi. There's a picture I take out of the window of my condo, these pictures. And this one is kind of, it's called the sky of doom. It's just fog. There's nothing doom here. I suppose if you have asthma, it could be doom from fog. And this is the one I took in a little bit of sun. It's a fog sunset. And that's the other direction from my condo. And that's between this is the Hyatt, called Diamond Head, and this is the Diamond Head Tower, and this is the, the Waikiki Beach Tower. And I have another one that's taken 2 weeks later, and what I wonder if I had waited till the sun was down, that you'd get this. The sky, that's fog up in the sky, and the sun is gone. Both your eyes and the camera adjust to the light. So now this is light enough, with that correction of your eyes, that the whole sky looks bright from the fog. And that's, Ansel Adams, that picture of the sunset with the moon on it. And actually, I was angry because I wanted to go take the sunset. And I was walking down Lily Kalani, and these tourists were walking so slow, and I said, I'll miss the sunset, I'll miss the sunset. And I got down there, and they slowed me down enough so it's getting dark enough you can see the moon. So I was grumbling for nothing. But that's kind of an Ansel Adams addition to that. Okay. How do you get this? There it is right here. Okay, this is, oh, now I did something wrong here. I hit the wrong one. Now I got to find that one again. Uh-oh, I've lost everything.
Get rid of that. That's your old.
I lost the original one that I had, this number 1. Okay, we'll get that again.
So just a double. Yeah, you got it. There you
Got to hit it twice. There we go. Now I'll get my button. I'm not used to this computer.
go. That's the one.
Okay, this is what he's talking about. I've actually changed the name of the ebook of software development because I want to emphasize I'm doing software development with hermeneutics. And I think in the original, they should have taken that approach instead of Jordan's approach. And Jordan's is a form of hermeneutics, but it's very, very, limited. Everything is function and structure, and everything else is ignored. And as part of the book, it's to emphasize the use of broader way of looking at a system in order to develop a system that takes in all the problems we have, not just function problems. And I base it on Foucault and Habermas and Ricoeur. And Foucault has a system where you go into a system of, where there's a lot of information, and you look at it as an archaeological site. And that's what they say, you go into the system, you look at it as an archaeological site. Other people may know other things, but when you start into that, that's the best way to look at it. And you look for artifacts, and then you find where the artifacts are similar. And you do that, they call that layering. And it's the same thing to do in archaeology when they're digging up the holes in the ground. And you think, oh, these go together, we can tell that by certain keys and understanding. So you find the meaning of this whole pile of garbage that you get in a systems study. Don't tell your people that's garbage, but that's what it is to you to begin with. And then you use Habermas. When you get the meaning of the system from Foucault, you take Habermas and find out how you can use that. Habermas is one that the meaning of a word is in its usability. And so you develop usability. And Ricoeur spreads out the understanding of the project in what they call distantiation, where you look at the whole meaning of different text and other information you get on the system. The ebook on computer design I'm showing how you actually plug the wires together. If you start at the beginning and the end, you'll be able to build your own computer in a sense. So it's a different way of approaching the architecture of a computer. They're under Google Books. This lecture is up here. Sites, Google.com site, Lessons on Distributed Computing. And the one I did last year was lessons on the internet. Go back to this screen, I think, if I can get there without losing the screen. That's not the right screen. No. I got too many things here. I got to get rid of some of these.
Yeah, what you have to do is be careful. You have only one finger on the thing.
Now I get to one thing.
Yeah.
That'll help.
Because you're keeping one finger on there that you can't. You gotta just
Can't do it, yeah.
you gotta take that hand off.
Oh, the hand is, oh, you got two fingers and then it won't work. Okay.
Yeah.
That one should shut down, and then this is the one I want here, the
Number
second
two.
one.
Okay.
That's it, there. Okay.
So yeah, if you're touching that pad, it's trying to do stuff.
Got one finger at a time, all right. Did it go? No, it didn't go. Oh, I'm having trouble with my hands too. Okay.
And then,
There we go. Okay. This is. I am following the Leo's book on what is this computer? Like we call it the distributed computing. I couldn't think of that word. In Leo's book, she goes into the paradigms. I found no one else to do this paradigms, but if you go to studies on the internet, they'll go through this. I don't know why other textbooks don't do that. Okay, the simplest one is message passing. The hard part of this is both computers have to be up, and they contact each other directly, and they also have to be ready to give a message and ready to get a message. But it's absolutely simple. There's very little. This is easy to do once you have both computers going, message passing. We're used to email, which is a lot more complicated than this, but it does a lot of things for us when you're doing the same thing in email. There's no queuing or store and forward. It's just the message goes directly, or it doesn't go. It just gets lost if it doesn't go directly. Okay. Client server, this is the standard for the internet, and I think we all know dealing with the client server type of system. Okay, there we go. A client can ask something of the server, and then the server responds. But there's a lot of different things that are done this way, where we're talking to a server and the server does things for us. And this is the sort of almost the standard for doing things on the internet, some kind of client-server processing. And other things may be going on too when you're doing client-server. We're going through other of these different paradigms. Other paradigms may be operating at the same time. Client-server is kind of the mother of it all. Peer-to-peer, I think the client-server was invented first. This maybe should have been, but then they decided, back then you had if servers were quite expensive, so some companies said, we want to do that, but we don't want a big server. So then they develop a peer-to-peer network. It's just the computers you have this office, and all the computers are on the peer-to-peer network. And you can send request either direction. It's, they're all kind of clients and they're all kind of servers. And everything's is kind of equal. One of them may be the one that maintains the network itself. But other than that, it's nothing. It's just computers talking to each other. Actually, you can set up servers with a rather inexpensive computer today, so you don't necessarily need a peer-to-peer network. You can put a computer and say, well, this one will make that our server, and a lot of the server stuff can be done especially in a small office. And this is the email system, a little more complicated than the messaging. And you see the receiver already has a list of emails that it's gotten. And you send a new message, and it added to the list. When you turn your computer on or turn email on, you get this extra message. So it has this, the messaging is decoupled. You don't have to have both computers on, ready to talk to each other. They send you the email in the background, and you get ready to read it, you go read it. Then you can send an email back. Asynchronous, non-blocking. Neither side has to block to do it. You just send it off, and you go on with your work. The other end, they go on with their work until they read the email. You don't have to have where you're in the middle of an application, you can't send it until you shut everything else down and send it. That's kind of what blocking means. Okay. This is more information on how email works. Y'all kind of know all this. The email is actually a middleware for this kind of messaging. I'll get into email later. And then you have the publish, subscribe, and this is the part I hate, but I get in these lists, and they're sending this junk email every month. And, like I just delete it, after a while. And most of them will have an unsubscribe. You get, okay, I don't want this notice from your people anymore, unsubscribe. If they're honorable, they'll give you the unsubscribe and you can shut it down. Okay, remote procedure call is different than email. It generally is done with it's done with a client server where the client's asking a server for these procedures, but it can be from any computer to any other computer on the internet. And the idea is you have a procedure call. You're running an application and it wants to use a procedure somebody else has made available. It calls the procedure on your computer. And what a remote procedure call is, you're doing it on somebody else's computer. There's a process there you want to call. Makes it more complicated. There are all kinds of problems with making it work right, but they have systems that make this work. In the process, the procedure call, they call it as marshaled. It's put into packets, so it can be sent across the internet to the other computer. On the other computer, it does something, so it turns it into a procedure call there. It comes back. The return value is returned through the internet in packets. It's supposed to look as transparent as you can. Because there's problems with it, it's not totally transparent that you're going to another computer. Okay, distributed objects, it's the same concept, but you're dealing with objects rather than procedures. So you're actually doing the same thing, but you're in an object-oriented language, and The objects, I have process B, that's an object you have over there you're going to call. The object has a lot of functionality. So you call the object from your computer, and then you can do things with that object. And it can be more transparent to do the object. So you remotely call it, you get a response. Object request broker, this doesn't have little circles and arrows going on, but this is like Corba. I guess Java RMI has a similar thing. It's just saying you request an object, this request broker handles that request. So what I was doing in the previous one, you're doing it through this middleware. It's using the internet, but it sort of takes over the whole transaction. And so it can be more transparent when you're doing, and this can do both object requests, it can do procedure calls. They call it middleware. A middleware is actually, in my view, if I get to that, the tiers, and I think that's the next lecture is on tiers, modules, and processes. And this is kind of like a tier in the system, because it appears that that's a layer in the software that's doing this for you. And so it does this mediator and brokering. So a lot of this problem with going from one computer to another that makes it less transparent, this makes it more transparent. What transparent means, you don't know you went to another computer to do it. And you have no idea, no clue. And these brokers are able, like this is a PC computer. At home I have an Apple. There are other computer systems. There are computer systems with different operating systems, different, systems going in there, what kind of network you have and all that kind of thing. You're going through different networks as you're calling from one computer to another. This middleware is designed to handle all that. So it isn't bothered when you go from one kind of computer to another. You're not supposed to be bothered by it anyway. Object space, when I was taking my PhD, the professors in computer science were all working on this kind of thing. And the idea is you've got a systems analysis project, and most of them were around that type of thing, a systems analysis project. And okay, you want to set it up so different people can work on that project together. So you have, in this case, a provider of an object program that will handle, your systems analysis. And then different people can go in and use this software. And the logical end of the object spaces, the professors my professors were able to do this. They actually set it up so this kind of thing worked. And it's kind of a virtual space. Later on in this, we'll get to other ways of doing this same kind of thing, which to me, are they really different than object spaces? Now, in most cases that they were working on, as this was like a project people working on together, people could change the project. And so you'd go in and put something in, I don't think that's right, I'll change that. So you can change what's going on in the object space. And so you could work on this project together. This is an interesting one, and this is what viruses are all about, but also is used with functional software. You have some kind of an agent, sometimes they call it a spider, and it actually can move from one place the internet to another on its own and do different jobs. And so it may have an itinerary, probably has some kind of, how does it go to the next spot? And whatever it does, and like a spider is sent out by the Google, some kind of a search engine, to go around and look at websites to see what's on them. You just spend all the time doing that. So whatever task it does. Well, in a sense, viruses do the same kind of thing, but they're not doing it legally or nicely. They're trying to destroy your system. Okay, this is network service. This is like DNS. And I learned about this when I was at the university. We'd be working on projects. This is like we were teaching networking in their computer science lab for the computer science class. And we would be setting up the stuff for the students. And all of a sudden, we couldn't get to our goals. We would say, we'd ask for, if this was another server at the university, and it couldn't find it. Well, the directory service was down. Why that would be, I don't think you have trouble like that we had back then. So then some of the lab technicians memorized the IP address. And so they come out, oh, you can get there here, and they give you the IP, and you didn't have to use the name. You'd have that. You'd have the number that was used. But that's what the DNS is supposed to do, is give you that IP address, and then you can get to the service you require. And it's locally, say at the university, that would be on the local server somewhere. So it's a server that's fairly close by. But then if you ask for something in Timbuktu, well, then it has to go out to a second DNS server, and there's kind of automatic means to do that. So you can get whatever service you need. Now, I mentioned early the calling a remote procedure. To do that, you have to have this type of thing for calling procedures. The DNS is for the internet connection, but you want to know where remote procedures are, you have to have this kind of service available to do procedures. And here's some other collaborative things that you can do. This is just everybody can talk to everybody in there, and while they're talking to each other, to really work, you have to know what everybody said to everybody else. And so you can do a project this way. And it's multicasting. I find this is more like an object space. This is a better way of doing it, because then it's kind of the results are on a central location somewhere, probably on a server somewhere. And they're a good way to run a project with a group of people. And this is all from M.L. Louis, I don't know if that, Liu, M.L. Liu, Distributed Computing Principles and Applications. And, it's very program-oriented, it's very technical. If you just ignore this one, I ignored the technical part and got the meat of to me, the important issues for this. But if you want to get to something very technical, it's one of the more technical books on distributed computing. Where is the mouse here? can't find the mouse. I'm not doing it right or something here. The mouse, there it is, finally.
So get rid of this
Just
one.
get rid of that one and I'll go to the next one.
313.
That one there,
Tiers.
yeah.
Okay.
See what that is. Okay. This I promised earlier, the tiers, modules, and processes. That's another way of dividing up what's going on in distributed computing. The tiers is a kind of a strange one, but actually, as you start working, you realize, oh, that's a layer in all this software, and it's not just on one computer. Like middleware is going on all the computers in your system, in your laboratory. It's going through all of them, and it handles these processes. But it's a layer. You're talking to it, and then it talks to somebody else. Like you're going down in layers as you do the processing. Okay. Let's see. I got on the back one. I think I got on the wrong one. This is the last. Let me get out of here. Go to the top. There we go. Now I'll start it again.
Yeah, right here. That's it.
There we go. Now we'll start with the bottom. That was the last lecture. The thing was pointed to the last lecture. A process. It went back to the last one again. What happened here? I want it up here. That's on that one. Now let's try it here. There we go.
Oh, whoa, whoa, whoa.
Oh, I lost it. What happened to it? Oh, it jumped on me. Okay.
Went back to
It went back to the process one. Why is it doing that? Maybe when I'm moving around, I went back to that one. There we go. Oh, it went right back to processes. Now I got it. Now I think I got it tiers. There, we're at tiers.
That's where you wanted it?
That's where I went. Anyway, the computer's fighting me here. Tiers, they have to do with architecture, and that's why it appears like it's a layer in the architecture of your system. It went all the way back to I must have hit the bottom. I know what I did. I'm hitting this button on the bottom here. No, it doesn't want to go to well, we'll start that way. Well, I'll just read through the thing. They aren't necessarily physical tiers. They're tiers in the software. Sometimes you'll have like, this computer is a client, this computer does something else. It's a tier, and this computer down here is like the database. And those are the tiers are actually on computers. But it doesn't have to be that way. You see the picture kind of looks like that, and you can picture it even though the tier is going to all like middleware. You can picture like that's a separate server almost. It has that kind of view. Oh wow, it's jumping to the end of the article here. There we got down to the bottom, okay. Now, one of the common ones they describe in the literature is business rules. I've always worked in small companies, and they don't have this kind of thing. But if you work for a large company, maybe even the DoD, you're going to have business rules so that everybody's working on the same basis. That's a tier in the whole process. So when you do something, you go through the business rules, to make sure that what you're doing follows the rules. And then you go on, say you go to the database or something. And that's a definite tier in the system. One of the reasons why the database is a separate tier is partly security. If you bury it under all of these tiers, and there's a database down here in the bottom of all those tiers, there's security in having to go through all those tiers to get that. Each tier can have its own kind of security to prevent people that aren't supposed to get to the database. Because the database is a valuable of the company. It's who we are. Let's see if I can get this. And that went all the way to processes too. Okay, modules refer to distinct divisions of the application. When I consider modules something like when you're in a spreadsheet, Excel, or notes in or numbers, I guess they call it, in Apple. You go when you're in the main part of that, making up spreadsheets, you're in one module. And then you want to make a chart, you actually go to a different, separate module. And that's kind of what I'm referring to as a module, completely different. But modules, going back to Jordan and his development of structured design, a module is actually anything you call. It can be any procedure, anything that can be considered a module. And he draws his drawings. But I'm tending to refer to this as a larger grouping of modules. And the key is that the module operates on its own. You give it a bunch of data, say from the spreadsheet, you give it some data, use this data, make a chart, and it uses the minimum data. It doesn't know the other data on the spreadsheet, just the data you give it. So you have this consistent functioning. It's doing a certain kind of consistent functioning. See if I can get to the rest of that now. Get the whole thing. But you have minimum data exchange between them. When you're in this module, you're not going back and forth all the time. Oh, I want to go back. You just stay in that module, work on the module. I don't know why this one wants to go to this all the time, but let's see if we can go through this. Process, and I'm referring, you're seeing get to the top level, very complicated processes. A module is a little less complicated, but still fairly big. And a process really refers to just something you do on the computer. So it's a set of commands that are in a row. That's a process. Or it can be a whole 6 pages. This process requires 6 pages, yeah.
Your statement up there states that the process is less structured.
What's that?
Your statement states that the process is less structured.
Yeah, it's not necessarily structured anyway. It's just a bunch of commands.
Because usually if it's a sequential or if there's a particular process or way to do something, to me that's a more structured
Yeah.
than a less structured. So I'm just trying to understand.
If you specify this kind of process, then you might be more structured. I'm saying anything you do in a set of commands on the computer is a process. That's how I'm defining it, and I find, most of my reading, that's the way they're defining process. It's a lot less structured. It's just something you do on the computer. Whereas a procedure is defined as a specific type of thing. It does a function, and then it only communicates at a minimum with other procedures.
Okay.
And a tier is this thing that just, it's a layer in the whole system.
Delineation of how you're doing a particular interaction.
So when you get down, you're doing all the systems analysis, you get all the procedures, you get all the tiers, you get all the modules, you get all that. So this is what we're going to do. And you get down and you start writing it. In a sense, you're writing processes. I will do this one with this process. And it can be more, it can, you can be referring us 6 pages of code as a process. And I've had some of this is a process and it's taken 6 pages to do this process. But it's all one process in a sense. In structure design, the activity is to put processes into modules, and so that they follow the rules of structure design. Okay, any other questions? Now to some extent, this is my way of dividing it up as we went through the study of what was going on in the internet. These types of things recurred over and over again. So I kind of want to break it down. This is one way to break it down that you can understand what we're talking about now when you're doing things like this. I didn't even find the mouse.
What happens is you move it
Off the side of the screen or something.
There it is.
There it is.
It goes, so it usually has gone off.
Oh, it's way going. It's ends up way off in there.
Okay, so.
Okay,
14.
this would be the 14. Yeah. And this goes into a little more detail in the domain name server. You have a computer, you have a resource that you want, and you have the DNS, and DNS is kind of a black box to us. We don't, well, I guess I was familiar with people setting this up. I had to work with them to how you added new websites. State of Washington, we were in charge of setting up new websites. And so I didn't, somebody else did this, but I didn't know how they did it. So it isn't totally a black box, but for most people, it's just a black box that does stuff for you. And this is when I was at Metro State, and you call the DNS, and it comes back with the IP address, and then the system can call that IP address, gets your call to that computer, and here you're asking for this folder. I'll go more into what that folder is. It's a special folder in the local server. It was my website at Metro State. The DNS it takes the closest server that can find your address. If you're, like I say, if you're going to Timbuktu, it may have to go out to further DNSs to get the actual result. They're fairly fast to get the information you want. Okay, these are just, when you interpret it, the EDU here, this is at a school, so it's EDU. The EDU gives you your a starting point. And then all of the websites under EDU are in that list. You have COM, that's another list. ORG, that's another list. Then the rest of the name, and you got to read where the slash is, the DNS ignores that. After the first slash, that's directions for the server. And it's usually folders, and sometimes there's a lot of gobbledygook in there too for that server to use, but it uses the stuff before the first slash. So somehow it's associated with Metro State University. It'll go into some list of websites that they have listed in the DNS, they can find it sometimes right there. You know, they don't have to go any further. Okay, EDU, that's the section. Then it goes Metro State, and it leaves that off. That goes somewhere else. Then I'm not sure if it goes to the site to check out more information on that. I thought at one time it did. I'm not sure that this avenue is, but somewhere in here it returns the IP address, and then you can call the page.
The relief of the DNS server uses an A record.
What's that?
Fully qualified domain.
What's that?
So the domain server uses an A record, and it uses a fully qualified domain name to register that to an IP address. So when you're sending it forward, it recognizes that fully qualified domain name, which is www.metrostate.edu, and it says, this belongs to this group, here's the IP, here's how you go. And the client then adds on the after slash to the actual fully qualified.
Everything after the slash is only for the server when you
for
get there.
the
Yeah.
inside server.
Yeah. And that the slash JE or JB Heath is for my website, and and on a Microsoft computer, it's the folder is JB Heath slash public HTML, and that's your website. It's on that public HTML folder. It's done differently, and I used to know what it was on the Unix, but it's done differently. But it's the same kind of thing. You're calling my particular folder on a Unix server. I don't know what happens to this. I'm on it somewhere, but I don't see the mouse. The
So
mouse
it's always-
is too
it
small.
seems to always land off on the right,
Yeah.
the extended desktop. So you want to get out of this one?
Yeah, and doing the 15.
Number 15. So yeah, when
Let's
you-
just start this one up, yeah. Okay, I like to picture this. I've done, this distributed stuff, and this is from my experience of doing different stuff and, reading about what problems people have with distributed systems. And I like to picture, a bunch of computers all connected together on the network, different ways. Okay, this is talking about a process, can call a process in another computer, and then get a return. I'm just presenting it simply here. And that's part of what the value of the internet is. All the processing doesn't have to be on one computer. You get a bunch of computers together, and they're more powerful than a mainframe, being able to do stuff like that. So there's a whole bunch of things you have to do. That's part of these brokers help handle that kind of thing. You go from one to the other. If there's more than one source, how do you decide which one to use? The brokers are supposed to handle all that kind of thing. This is a rule they all state. When you do it on your own computer, you can say exactly once is possible when you call a procedure. On the internet, and I go through some reasons why that you can't depend on that, but you can come close to that, but you can't guarantee exactly once. When you call a procedure, that's what you want, exactly once. Okay, and this is what we had problems when we were working on developing software on the internet, is caching. They're caching of stuff on another machine. You call the procedure another machine. then it caches the result. And then you call it again, it'll use that result. But you actually asked for something different this time, but it goes to the cache. A lady was putting in, they were shutting down their mainframes and putting everything on plain, small computers on a web application. And she started out to investigate this one application that was on the mainframe. And they said, no, just change it now. So she was rewriting the application on an HTML system on the PC-like computers. And she was having trouble that she would make changes to the code. And then she would call it to see if the changes showed up, and they didn't because it was caching. So she actually had to go in and delete the cache. She had to find where the cache was, delete it, so when she'd make a change, it would rerun the software. And caching be a real problem to programmers that way. I was doing the same kind of thing. I guess I was a little ahead of her, and I'd already figured out, and she asked me how to do some of that. I helped her get rid of her caches. Because I was doing the same kind of programming myself. Okay, and I go into this, when you're calling different stuff from different places, and some of the problems you come into. I'll show it in pictures. Okay, critical section. The critical section on a mainframe computer, everybody's on the same computer, and one computer asks for this process from somewhere else. Probably the most common is asked for a disk read. Okay, now another process, that process times out. Another process wants a disk read, but the disk is tied up with the disk read from the other one. If the new process comes in, well, it'll come out as just junk. You won't get anything. So that the critical section is while you're doing the disk read, no one else can go in and read the disk. That's a critical section in a code. And there are lots of critical sections. Well, in the internet, it's even more. And I'll show some pictures of that kind of thing going on. Because you're going on different computers, and I call this process, well, maybe this computer can call it process too. And if it's in a critical section, if it's running that section, somebody else can't go in and gobble up that section because it just destroys the whole thing. So once a disk controller started, you lock the disk controller. Nobody else can touch it until it's done with this process. Well, if somebody times out or somebody is not available or something, well, the disk can't complete the process. So everybody has to wait. Some of these brokers that are the middle tiers try to resolve some of these issues so it doesn't just shut everybody down. Okay, let's see. Okay, there's a process called. Now another process calls that same process. And you end up with garbage if you try to run both of them. So let's look at it again. This one calls that process. Second process calls it too, but it can't call that process because it's being used by somebody else. And what happens is, particularly in object-oriented, you can do it this way, easier. You just call another copy. You create another object and create another copy of it. And then both of them get what they want. You see all this in across a whole network with everybody doing all kinds of things, you have this kind of problem coming up all the time. In the critical section, they in the mainframe, they'd set up, a monitor or a semaphore which literally kind of locked the system until you could use it again. Okay, this is the disk read. The issue with the disk read, when you're reading the disk, the computer bus is busy with the disk read. The information from the disk goes out of the computer bus and it goes to the addresses taken off the section of the disk. And so somebody else starts messing around and it just shuts everything down. Disk controller, you've got to realize in a lot of these little operating systems inside computers and in servers and everything else, these operating systems don't understand the whole system. They understand their little job. So, and to make it efficient, they have to be that way. So these other things that could happen have to be handled by some other process, like having a monitor or a semaphore. Okay, now this is, I'm talking about databases, and this should not be turned on yet. This is about the printer. But databases is even more complicated, but the people that build the databases provide all this processing. So you as when you're going into the database, you don't have to worry about that other people, that you might cross over with other people. You might be delayed in getting your information. But the database handles all this. So one person is reading it, well, you can't read what that person is reading, but you can read something else in the database. The printer is something that they solve the problem of this kind of thing for when a printer's printing, that's a critical time. But rather than worry about it, they set up a queue. And if you print, you notice this is happening, you get put in the queue, and the queue holds the data you're having printed. It's in that queue. So you get there and it just prints that. So once you ask for your print, you could go do something else and ignore it, and go over later and pick your stuff up at the printer. You don't have to worry about it. Now, there is a critical section when they're setting up, and that's a very short critical section when they're setting up your print on the queue. During that time, somebody else can't be setting up a print queue. They have to wait to set up their queue until you're done. But it's a very, very short time for that. Queue process is very robust, and there were times when printers gave you headaches all the time, but they've solved a lot of that in software that really cleans up the mess, and you can trust your printer that you're not going to get any of these. We used to get in this, once there was an error in a printer, no one could print. And the other thing was you couldn't stop the error because the error would jump back and forth between the printer and the computer that asked for the print. So you'd kill the error in the printer, and it'd come back because it come from the whatever computer had asked for the print. They've solved all those problems. It doesn't seem we don't get into that anymore. Okay. This is on having more than one source of files. When you have all these files and everybody's using them, if it's all on one computer, it can be a problem. So they have, you can put files on more than one computer. There's going to be lots of problems with that. Okay, we have 3 different computers the files are on. Somebody changes something. These other two files are out of date. What do we do? What are the rules for what we do? So you update, and you have some kind of schedule for updating, and then you have synchronization. The updating is, well, if enough changes have been made, we just update. The synchronization is that every so often we synchronize all our databases. And in many cases, that's once a day. And that may be good enough to synchronize. And now when you have, oh, I missed something there. Here it is. Okay, here it shows, I missed the data up here. Your two different files, you have two different files on different computers that are updated. Okay, now how do you synchronize? And you got to have a rule. And most of the time they say, the last one updated is the standard. That one, in other words, this one's updated, and then this one's updated later, then that's the one that's you're synchronized on. It may not be right, because the person that put this data might have put the correct data, and this person put the wrong data, but you've got to have some kind of rule. Okay, now we're talking about something like caching and holding information while you're processing. And, okay, where you store it depends on how quick you can get at it, and how much data you can store, because you start holding it fairly close to the CPU, you have a smaller cache to deal with. So you can actually put cache in RAM memory, and that's done. Actually, some of the caches for web use are on the disk, because the disk is closer than the other end of the internet. So that's the cache on the disk, which is slow, but it's faster than getting something from the internet. You can have special caching. This is picturing main memory and some kind of cache that's close to the CPU, or even they have a small cache in the CPUs anymore. There's a difference in speed. As I draw this, the further away you are from the CPU, the longer the time. Partly because it is further away, and partly because it's got a larger memory, and it takes more time to actually address the particular memory that you need. A primary cache in the CPU is almost like a register. Registers are immediate. If information in a register, you can process that immediately. A primary cache is almost that close. It's not quite. Although I think in the modern CPUs, they do a lot of, virtual registers, and those are very likely have to be in a primary cache. Secondary cache, it's not in main memory, but it can get at a lot faster than main memory. And then you have the main memory. And of course, like I said, you could cache on the disk. RAM is fairly fast compared with the disk. It's a lot faster. Somebody explained it to me this way. If you're making chocolate chip cookies in your kitchen, everything on the table, that's like main memory. If you find you're at the end and you forgot the walnuts and you have to go down to the grocery store to get walnuts, the timing for that is relatively the same as going to the disk rather than going to RAM. It's that kind of extreme difference. And the caches, the secondary cache and the primary cache are much faster. And if you can have everything you need for processing for this application in both of those, it doesn't have to go to RAM even, and it doesn't go off the disk, which is really slow. Any questions about that? I found the mouse.
Oh, you did? Okay, good.
Found the mouse. Now we want to go
16.
distributed.
And then just a double click.
Yeah, let's do that one. I'm getting
Sure?
close to the end. Let's do this one. Yeah, this one goes into more into what middleware is about. Okay. Back to the bunch of computers connected to a network. And this just shows the fact that when you're calling a procedure on another computer, you're using the web. You're going into packets somewhere along the way. Okay. The idea is what you want is fairly transparent. To do this, it's like calling it on your own computer. You're not doing something special. And actually, you need to do something special, but you have software that pretends that you're doing not so special things. And then you need this new kind of software, it's called middleware, that handles this kind of processing. And middleware handles remote procedure calls and remote method invocations. Okay. This is a computer by itself without a network. It has a system hardware, operating system, and then applications. I left room here because we do more than that now. You have now network hardware. But the network hardware has to put netware between your application and the operating system so it can use the hardware. And now even squeezing in between the application network, you have to have this middleware so the middleware can intervene and do what it needs to do without, even this netware it has to be simple to do what it's doing, and when you want to try to do something complicated, you can't. So the middleware has to intervene and do that for it. Now the middleware is the virtual path. That's the path it gives you that you're going through to process things. But the actual path is it has to go through the network. And the middleware is not actually connected to the network. It goes through the network by going down through the loop and contacting other computers through the network. Okay, problems with internet use. There's all kinds of web applications, all kinds of web service applets, file servers, print servers, thin client. At the state of Washington, we were fighting the thin client. We wanted our data on our own computers. And the state was trying to do this in a thin client. It's kind of like mainframe terminal computing. You have this server farm that takes care of all your applications, your processing, and you have this terminal that just tells it what to do. When you log on, it downloads your framework that you're working on. It gives you your screens you have and all that. But none of it is on your computer. They have all of your data on, you're on a kind of a file server or something where all your data is there on that computer, but it's not on your computer, it's under their auspices. We didn't want it. While I was there, we managed to succeed. It's a neat system because you get up from your desk and you walk over to another computer and log into that computer and tell that computer who you are. You get the same stuff you would have in your own computer. That's an advantage of it. Now you have more mobile. You can go around and connect up through Wi-Fi or through the network or something. And now we have chips everywhere. I don't know, your toaster has a chip in it, maybe not, but your refrigerator probably does. There's some kind of a chip where you can do some kind of calculation. The little CPU chip for this are so inexpensive that they can put it everywhere. And I mean, if it's hooked up, your refrigerator's hooked up to the network, your neighbor can turn your refrigerator on and off if they want to, I think. But anyway. Okay, and there's all kinds of software. It's all on the network. It's openness. The internet was designed to be open. Maybe we wish you hadn't made that design so you can have some security, but it's just anybody can go anywhere, so to speak. Scalability, I'll talk a little bit more about that later, but it's when you make changes and people come in and you get more clients and more clients, does it do it seamlessly? You don't notice that now we have a lot more customers or whatever. Okay, and the failures, if you're in a network, if you want one thing, if that computer fails, you don't want it to shut down all the computers at the network. So you want to be able to detect a failure, mask the failure so it can operate without solving it even, but you can go around it and tolerating it and then recover from the error. And concurrency, a lot of processes going on, you don't lose a tail. And that's happened to me. Or I'm going along processing, all of a sudden, what happened? It's gone. And transparency, you don't know that it's on a network. If you get to that point where you don't know or understand or how the network works and you still do all your stuff, that's transparency. Okay, again, there's all kinds of different stuff on here. I've denial of service, when I wrote this was one of the big issues on security. There's a lot worse ones than that. This is the idea of scalability. You start with 10 users. Anybody can write an application that'll have 10 people. Should be able to. You go to 1,000, that's a lot of people. You're going to have problems. One company we're at, we had this thing, we tested it with like 10 people. And it worked fine. And then everybody got on it and it just shut down. And they had to re-examine their procedures to do things because it was taking too long to sort things out and move around to where it was supposed to do. 1,000 users, or 1 million users, 1,000, then 1 million. When you get to 1 million users, you're talking about that's the problem they had with these large companies like Google and Amazon. And there's certain methodology to handle that kind of number of people. It's a whole different thought process. A failure shouldn't shut down the whole system. Multitask without getting confused between the different places, and you don't know you're distributed. Okay, I'll get into this. This is a middleware application. if you're on middleware, this is the actual path, the upper path, that's the virtual path that it goes through. And it goes all the way through. And it has to go through the middleware, both the beginning and the end. The middleware sends itself messages so it can do the things it needs to do to get through the whole process. And then when it's all done, the application goes on from where it asks for the procedure. Any questions about that? I think I'm getting to a point where I have to go to, I'm not going to get all my stuff done
So
here.
swiping from
There it is, right there. Okay, what do we want here? I'm going to do this. I think this is the one. Yeah, I'm going to do this one. This is the. I have some on the website for the stack frame. It's one of the best. It's the best stack frame description I've seen anywhere. In fact, I think people looked at mine and other people have put on web similar to mine, because I had this. The stack frame was explained to me by a teacher, and he knew it pretty well, but he didn't know well enough for me, and I wasn't happy. So I did a lot of research on stack frames. This is stack frame under a remote procedure. And you're going to call, we're in the remote, we're going back to that other thing. Let me get out of here. Let's escape from this. We're starting with I want to start with local, and if I get time here. Oh, wow.
Yeah.
Now let's see. Oh, where are we at here?
You can only put one finger on the pad as soon as you put the other.
I'm on the wrong one. Yeah, I got to get the other one in there. Somehow I closed the other one. When I hit, it's on that one. Okay. Let's go back to this. I got to pull the thing down. Oh, there you go. Now let's see, remote. Let's get a Q1, the 19 Q1 there, that one. I'm pretty sure that's the right one. Let's do that one. I don't get to sockets.
That is Q19, Q1.
Wait, that's not the one either. Wow. Oh yeah, that's it. That's local. Okay. You got to get the local process. Okay, that's where I'm going to get at. The local process, so a comparison to remote process. Okay, you're going to call a function, and this shows the build-up of the stack and the calling the function and the return value. The stack is used for when you're calling a process, it builds up the stack of information needed to call another process. There's the old stack that when you got to here, you have something left over in the stack from this process. So, and you call a procedure, you first put arguments on the stack. Then you put the return value pointer. This is a very controversial. You look it up, and people are saying it's all over the place. Now, this is for C++ programming, and this is where it goes, and I'm satisfied with that's where it goes for two reasons. Number one, it's where people who showed me assembly code for doing this process, which meant they knew how the process was done, put it here. The other thing, on the return from the epilogue, it has to be here. It can't be anywhere else. Well, it can be before the arguments, but most of them says it's put after the arguments. I don't know why, but it is. The return address. This is the one that's very important where it's at. The return address is the address that is the next address in the code. You're writing code out, you're doing this code, and it's running to here. Now it's calling a procedure. There's a next command. This is the address of that next command. Then they do this strange thing with the base pointer. The address of the old base pointer is put into this next address in the stack, and it's then given the name base pointer. So the base pointer is pointing at the old address of the base pointer from the old stack, so don't lose it. Then they put locals and workspace. This is the locals and workspace. This belongs to the called program. The called program needs space to work with, and rather than having it ask the operating system for space, it's put on the stack. So the local variables are the variables actually in the called procedure. The compiler knows what variables are there, so it knows what kind of space it has to leave. And then the workspace is if the called procedure has some mathematical or some kind of programming it needs extra space, it's provided on the stack. Now, when you call a procedure, you have registers in this program that are being used. You call that other procedure, it's going to use those same registers and destroy your work. So you push those stacks on the register, and you know which ones you need to push. So at the end, you put them back, so you're back where you started from when you get returned from the call. Okay, this local calls a local object. And this is how the processing goes. Number one, it knows where these addresses are of the arguments and of the locals and the workspace. When it's done processing, it sends the return value back to here, to the call. Yeah? 5 minutes? I'm done. Okay, well, I want to finish this other real quick. I'll go through real quick then. All right, you do that, and then it has to unwind the stack. The values put on the stack from registers are put back in the registers. I will go through this other one rather fast, but just see that the same thing has to be done when you're in a remote call. You start this, you build up the stack there, you call the other program, it builds a skeleton, you have a proxy here, you have a skeleton there, that builds up the stack on the other side, and then the return value comes back to the skeleton, it sends the return value back over the network, and unbuilds the stack. And so you build two stacks to make the process work. And any question? There are probably a lot of questions. This is on that lessons in distributed computing on the web, and the lectures are all there. And I don't have my voice. You have to read them, but most cases I give you enough time to read what I'm saying. Look on my one on stack. That's one of the best stack lectures in the world.